Check, what's going on? This is Quadratics 4. Let's get started on this. We've been looking at quadratics. We've basically been looking at parabolas and the different things that they do, right? I think one of the things that we talked about was we said if f of x equals a times x squared, ax squared plus b or something like that, or k or something like that. Let's make it k. We talked about if a parabola was in this form, then it will, you know how to graph this, right? We've graphed all these different parabolas. Please, that's very distracting. All right, so this k right here, what does that do? It will, you guys remember what we were talking about with this? What does this k do? What does that a number there do? You guys don't remember at all? All right, this is what I taught you guys back in January. All right, so look, this k right here, it will push the parabola up and down. That's what it does. Okay. If you don't know, then watch the videos from Quad 2 and learn it. This a right here, what that does is it opens up the parabola, closes up the parabola, or flips it upside down, depending on what type of number it is. Okay. All right. We also studied forms, equations of this form. I think it is f of x equals a times x minus h squared. Okay. If a parabola looks like this, then as you change this number over here, that will actually move the parabola right and left. Okay. So we've talked about this. This was quad 2, I think. This was quad 3. Quad 4 is we're doing something else, and it's something a little bit different. All right. This A property pretty much does the same thing, and maybe I might be even giving away too many secrets, but this number A right here, it still does the same thing that it did back here, where it will make it skinnier, it will make it fatter, or flip it upside down. And do you guys remember that discussion I had about the gummy bears? Yeah, see, you remember something, right? Right. So if A were a big number like the number 3, then that's me taking the gummy bears and stretching it out. And that makes the parabola skinnier, right? Whereas if A were some fraction like 1/3, then I'm taking that gummy bear and I'm crushing him between my fingers, and that's making the gummy bear fatter, so it makes your parabola fatter. I don't like thinking of it as fatter as much as I like thinking of it as crushing it between my fingers. You'll find out why later. I have my reasoning for that. If A were negative, that takes the whole graph and it just flips it upside down. Does that make sense? So that A is going to do the same thing as before, but this weird thing about R and S and what is the deal with that? I feel like you'll find it to be easier than you think. Okay? So let's start off with one property. It's called the zero property. And here, let's pretend I have some number A. Okay? And I have some number B. All right? And I multiply them together. That's what the dot means. And it equals 0. Okay? If A times B equals 0, there's some conclusions I can draw off of this. What is it? Yeah, exactly. Exactly. You weren't even here for the lecture. That makes sense, right? You can say either A equals 0 or B equals 0. Because if A were 0, it doesn't matter what B is. B could be a million. It could be a billion. It could be 1.3758964, whatever, times pi. If A is 0, everything is 0. The whole product is 0, right? On the other hand, B could be 0 and A can be whatever it wants. So if I have something times a second thing, and that product is 0, then I know that either the first thing or the second thing is 0, right? So check this out. If I want to solve a problem like this, x times x minus 2, and I say it's equal to 0, this is like x times this thing right here. I can either say that x is equal to 0 or x minus 2 is equal to 0. Right? I need to make x all by itself, by the way, so how would I get rid of this minus 2? There we go, add by 2. Add 2. So really x is equal to 2. That's what it's saying. Because this minus 2 and positive 2 cancel out. Does that make sense? Yeah. So what this is saying is, if this is your equation, x times x minus 2 is equal to 0, then either x is equal to 0 or x is equal to 2. X can be one of those two things. Does that make sense? And I mean, if we think about it, like, what I'm saying here is, watch, if I plug in x equals 0 into here, that would be 0 times 0 minus 2. By the way, 0 minus 2 is negative 2. But it doesn't matter because it's 0 times negative 2. It doesn't matter what that whole thing is because that whole thing is going to be 0 anyway. Vice versa, if I plug in x equals 2 into here, into this equation right here, that would be 2 times 2 minus 2, right? Right? You plug in 2 in for x over here. So it's 2 times 2 minus 2. But the 2 minus 2 over here, that's going to be 0, right? What's 2 minus 2? 0. And 2 times 0. That whole thing gets annihilated anyway, right? So those two numbers solve that problem right there. Right? It solves this equation. Either the 0 works or the 2 works. They both work. Does that make sense? Good. Do you understand this, really? Then you've pretty much got the bulk of the whole lesson right here. That is essentially what I'm teaching you. Let's try a few more. You guys are like, wow, this is kind of easy. Actually, it's not bad. All right. Okay. Let's try this one. This is saying x minus 3 times x plus 1 is equal to 0. By the way, I think I accidentally erased it. It should say equal to 0. Okay. What can you tell me about x? So what you say is, you're saying you know what you're telling me is this thing times that thing is equal to 0, right? So either equals 0 or what? Perfect. Speak up because the microphone can't hear you. I like your outfit, by the way. It looks very Blues Brother-ish. All right. So I want to get x all by itself. How do I do that? Please do it real quickly in your head. What is x equal to then? No, you're right. 3. Positive 3. Or what about here, Tejas? What is x? Nope. What is it? Negative 1. Because it's plus 1 over here, so you just moved it over to that side. It's negative 1. Does that make sense? So what I'm saying is either x can be 3 or negative 1. Cool? So you can choose? Well, no. It's both of those answers. Yeah. Does that make sense to you? Okay, good. All right. I'll tell you what. I know I showed you the answer right here. I'm going to erase it. But here's what I want you to do. I didn't see it. Well, good. Look at the equation and tell me what you think x can be equal to. Look at that problem right there and tell me what you think the answer is going to be. Either x is equal to some number or some other number. What are the two numbers? Look at the pattern here. You got it exactly. It's negative 2 and positive 4. I should write the word or there, or you know what I usually do is I put a comma in between there. It's either negative 2 or positive 4. And you understand what I mean, that it's you don't choose because, you know what I mean, what I mean is you can plug in negative 2 and that would make this first thing 0, right? Because negative 2 plus 2 is 0. And it would make this second thing like negative 6, but it doesn't matter what the second thing is because if the first thing was 0, then 0 times whatever is 0. Does that make sense? Also, if you plug in positive 4, that would be 4 plus 2. That would be 6 over there. But the second thing that you're multiplying it by would be 4 minus 4, which is 0. So it would kill it anyway. So both answers are both correct. That's what I mean. It's not just negative 2 is the only right answer. Positive 4 is the only right. No. Negative 2 and positive 4 both make this statement true. Yeah, they both end up in 0. Does that make sense? All right. Now here's what I want to do. Do you guys remember making tables? It's very easy and it's very tedious and it's a pain in the butt and all that kind of stuff. All I did over here on the left-hand side is I made a table and I said, all right, here's the function I want to plug it in. X minus 1, X minus 3. And then I said, okay, if the value of X were negative 2, then I'm going to take negative 2 and I'm going to plug it in for X over here. So that would be negative 2 minus 1 times negative 2 minus 3, right? Negative 2 minus 1, that's negative 3, times negative 2 minus 3, that's negative 5. What is negative 3 times negative 5? Positive 15, because a negative times a negative is a positive, and 3 times 5 is 15, right? Right. Hence is why I wrote 15 over there. Okay, so the corresponding number for negative 2, the x value of negative 2 gives you a y value of positive 15. Yeah. I went through and I chugged out all these numbers and I did all the scratch work over here. So you understand how to do this. And it gave me a nice little graph over here. Cool? All right. Here's what I'm going to show you though. Oh, wait. If I were to ask you, using the techniques that we just covered, x minus 1, x minus 3 equals 0. Let's do that problem. Okay. What are the values of x? Jordan, I think, got it. It's your turn to step it up, Tage.
X equals
3.
and x equals
1. Right? X equals 3 is right here. X equals 1 is right here. Right? How does this red graph, what's special about these black points on that red graph?
3 apart, 1 down.
No. What do you notice about those black points right there in this red graph?
X-axis.
They're on the x-axis, exactly. It's where the graph crosses the x-axis. That's what we're solving for. We're solving for the x-intercepts here. So when I ask you to solve this parabola over here, right, this is describing where the x-intercepts are. Where's the x-intercepts of this parabola? 3 and negative 1. Where's the x-intercepts of this parabola? Negative 2 and 4. Does that make sense? So that's all we're doing. Like, for example, what are the x-intercepts of that graph right there? Look at it. Yep, and so the way I graphed it is I just put a dot right here and put a dot right here, and I said, okay, well, the graph must look like that. I mean, imagine how easy, that's easy graphing a parabola. I just get those 2 points and be like, boop, there it is. Whoop, there it is. Yeah, exactly.
Oh, so you just need 2 points.
Well, technically you need 3 points, and let me talk to you about what the third point is. But let me stop the video, and I'm gonna start up a new one because I don't want these videos to be too long.